Ever wondered why a ballpoint pen can sit in your pocket, roll around in a bag, fall under your desk, and still not leak ink everywhere? It looks like one of the simplest objects we use every day, but inside that tiny metal tip is a surprisingly clever piece of engineering. Today on Knowledge Hub, we are looking at how ballpoint pens work, and how they control liquid ink so precisely that it only comes out when you actually write. At the very tip of the pen, there is a tiny metal ball, usually made from a hard material like steel, brass, or tungsten carbide. This ball sits inside a matching metal socket, almost like a miniature ball joint. The ball is free to rotate, but it is held so tightly that it cannot fall out. Behind it is the ink reservoir, filled with thick, oil-based ink. And this is the first big secret. Ballpoint pen ink is not watery like fountain pen ink. It is much more viscous, meaning it is thick and slow-moving. That thickness is important because if the ink was too thin, gravity would pull it straight through the tip and your pen would leak all over your paper, your shirt, or your bag. But because the ink is thick, it stays inside the cartridge until the ball starts moving. When you press the pen against paper and drag it across the surface, friction between the paper and the tiny ball makes the ball rotate. As it turns, the back side of the ball picks up a thin layer of ink from inside the pen, then rolls forward and deposits that ink onto the paper. So the ball is doing two jobs at the same time. It is acting like a door that blocks the ink from escaping, and it is also acting like a tiny rotating paint roller that carries just enough ink onto the page. The gap between the ball and its socket is extremely small. It is wide enough for a microscopic film of ink to pass through, but not wide enough for a large blob to leak out. This tiny clearance, combined with the thickness of the ink and surface tension, gives the pen its control. Surface tension makes the ink want to stick together instead of freely dripping away, while the narrow space around the ball meters the flow. That is why when the pen is not moving, the ink mostly stays where it is. But when the ball rotates, it continuously refreshes the ink film and transfers it to the paper in a smooth line. Some modern inks are even designed to behave differently, and they are moving. They can be thicker at rest, but flow more easily when the rolling ball applies shear force. This is why a pen can feel smooth while writing, but still resist leaking when left alone. Another important part is air pressure. As ink leaves the cartridge, a tiny amount of air must enter from the other end or through a controlled vent system, otherwise a vacuum would form and stop the ink from flowing. So the pen has to balance three things at once: ink moving toward the tip, air replacing the used ink, and the ball controlling exactly how much ink reaches the paper. This is also why some pens stop writing when held upside down for too long. In a normal ballpoint pen, gravity helps pull the ink toward the tip, but special pressurized pens, like space pens, use gas pressure behind the ink so they can write upside down, underwater, or even in low-gravity conditions. But for a normal everyday pen, the magic is mostly in that tiny ball and socket system. Too much space, and the pen leaks; too little space, and the ink cannot flow. Ink too thin, and it becomes messy. Ink too thick, and the pen feels dry and scratchy. So a good ballpoint pen is actually a carefully balanced fluid control device. The reason it works so well is because every part has a purpose. The thick ink resists leaking, the tiny ball seals the opening, the socket controls the gap, friction makes the ball rotate, and the paper pulls away just enough ink to leave a clean line. So the next time you pick up a cheap ballpoint pen and write something without even thinking about it, remember, you are holding a tiny machine that controls viscosity, friction, surface tension, pressure, and precision engineering all at once. If you've enjoyed this deep dive, don't forget to subscribe to Knowledge Hub for more fascinating explanations of the everyday technology shaping our world. And as always, stay curious.